Alright guys, so I don't have a lot of time on this video, so I'm going to probably go through this as quick as possible, but also trying to be detailed while doing it. So this test correction worksheet, or the redemption, it's going to be 10 extra points on your test if you turn it in by the deadline that I specify in class. Additionally, there's 4 sections. So as you can see, there's solve for y. At the bottom of this screen, there's graphing systems method. On the next page, I think there's elimination, and then substitution. Okay. So at the end of each of these sections, as I work through it, I want you taking notes as I'm working through it. And then when I finish the section, go ahead and pause it and attempt the problems on your own immediately after. Okay. Then you can press play and go on to the next section. My video, if you just let it play through, it's going to keep on running. So make sure you press pause. So I'm going to start with solving for y. Now, if you become comfortable enough with this, you don't have to do this, but for now, I would recommend it. Just put a line right through this equal sign for organizational purposes. Now, if I'm solving for y, I want to circle anything that has to do with the y. So I circle negative and 3. The negative tells me that it's a negative y, and the 3 tells me how many there are. So there's negative 3y. I circle the whole thing. I want to get rid of everything else. I want to move everything else to that other side. And that's my first step. So I'm going to minus x from this side, minus x from this side, because whatever you do to one side, you have to do to the other. Those x's are going to cancel. My negative 3y are going to come down. Remember, it's a negative 3y that's coming down, all right? That's going to be equal to negative x plus 12. Those are 2 separate things. The 12 doesn't have an x, so I leave it as 2 separate things. It's a terrible 12. Okay. So now I have a negative 3 being multiplied by y, so I'm going to divide by negative 3. Again, the reason I'm dividing by negative 3 is so I'll have a positive y left over, because a negative divided by a negative is a positive. So I want a positive 1y, and that's what negative 3 divided by negative 3 is. It's positive 1. Then I'm going to have a 1/3 x, or x divided by 3, it's the same thing. And then I'm going to have a negative, that's going to be a negative 4. Positive 12 divided by negative 3 is negative 4. And there you have it. I've solved for y. Now going on to the next one. First thing I want to do, again, a line for organizational purposes, just to keep it organized. I want to circle anything that has to do with that y. This is a positive y, so I'm going to circle that positive. It tells me what kind of y it is. It's a positive y. Then I want to get rid of anything else that's on that side. I want to move it to the other side. So I have a negative 3x. So I'm going to start by adding 3x. Notice it's almost the same steps every single time. These are going to cancel on the left side. I'm going to bring my positive y down. And then I'm going to have a positive 3x and a minus 6. Again, notice they're 2 separate things, so I keep them as 2 separate things. This one has an x, this one doesn't. And there we have it. That one's finished. So now I would pause the video, finish writing any notes you need to write, and then go ahead and try to solve it. You can always replay this video also if you get stuck when trying to solve it. Okay, so on to graphing systems. So in graphing systems, if we're going to graph something, we need y to be by itself on both equations. So we already have it on one equation. This one's good to go. But I need to solve the next one. And remember, when we graph a system of equations, what we're looking for is the place where those 2 lines are going to intersect. And that's going to be the solution. And what I mean by solution is it's going to be the x and y that, if they're plugged into these equations, they're going to satisfy both of the equations. It's going to be the only point that does that also, because we're talking about lines. They're only going to intersect at one spot, if they intersect at all. Okay, so this one's already in y equals, so now I need to make this one in y equals. So again, I need to solve for the y. So I'm going to pause for a second. What do I need to do if I'm going to solve for y? I need to circle anything that has to do with that y. Anything that has to do with it. Also, I need that line for organization, but that's not mandatory. You don't have to do the line. If you're good enough, don't do the line. Okay? Circle that negative 2y. Remember, that negative also comes with it, all right? That's what's going to come down. I'm going to subtract 5x from each side. Those are going to cancel on the left. So I should have negative 2y equals negative 5x minus 4. I'm going to divide by negative 2 because negative 2 is being multiplied by the y, and I want there to be a positive y left over. Negative 2, negative 2, negative 2. My computer just turned off. There we go. Divide by negative 2 on like each of these. So I should end up with, I guess, unfortunately, I'm going to have to write, or I'll skip over this graph. Kind of write, actually I'll just write inside y'all's notes. Okay, so here we go. Y equals 5 over 2 x plus 2. Now the reason I leave it as a fraction is because that's my rise and that's my run. So remember, our slope is rise over run. So if I have a positive 5 on the top, that's how much I'm going to be going up. If I have a 2 on the bottom, that's how much I'm going to be going right. Okay, if it's a negative 5, I'm going to be going down. If it's a negative 2 on the bottom, I'm going to be going left. So this is where I start. Notice this is y equals mx plus b. So here's, in my b, I've had a lot of people ask me, does it always have to be a positive because it's plus b? No, it can be negative. That's fine. B is just the number by itself, or the constant. And then my m is always going to be, or my slope is always going to be connected to that x, all right? So b, it could be a negative. This one's a positive, so I'm starting at positive 2. And then I'm going to go up 5 over 2, up 5 over 2. So here's up 5 over 2 is 1 point. And right here we can probably make our line, but let's go ahead and do one more. Now up 5 to the right 2 is the same thing as down 5 to the left 2. So I'm going to go down 5 on this one, left 2. And you can see all three of those dots line up. So let's go ahead and make our line right here. Now I'm terrible at making lines, but that's alright. I'm hoping this computer's battery lasts through this whole video also. Okay, so here's y equals x plus 5. Let's graph this one. So we start at positive 5 right here. And we're going up 1 over 1, 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 up 1 over 1. Right? So you can see all these are in a line. You can see that's my intersection point right there. So here's where they intersect. That's going to be at, looks like x equals 2 and y equals 7. So you can write it like this, x equals 2, y equals 7. Or you can write it like a coordinate, because it is a coordinate. Oops, sorry, that's supposed to be a 2. 2, 7, right? Over 2, up 7. That's where they intersect. That's the solution. If you plugged in 2 and 7 as x and y here, that should be the solution that satisfies both equations. Alright, so you can go ahead and pause the video and try your own. I'm going to move on. Here we go. So elimination, it's the idea that we're going to be adding these two equations together there, hopefully to cancel out one of the variables. The problem is right now, if we added these two equations together, I'd have 14x here, I'd have 8y, and then I'd have 18. So right now we can't add them together. We need to multiply these equations by something. So I put parentheses around the whole thing, multiply it by something so that either the x's or the y's are going to cancel. Now I want to get rid of the y's because they have smaller numbers in front. And we're going to use those numbers in front, or they're also called coefficients. We're going to use these coefficients to multiply with, okay? So on the top I'm going to multiply by 5 because that's the coefficient of the y on the bottom, okay? I'm going to multiply by 5. Then on the bottom I'm going to multiply by 3, which is the coefficient of the y on the top. And the reason we do that is because 3 times 5 is 15 and 5 times 3 is 15. The problem is, if we added 15 and 15 together, because those are both positive 15, we would end up with 30y. So we need to make one of these negative. It doesn't matter which one, I'm going to make the bottom one negative. Alright? Now I'm going to go ahead and multiply through. I've got 5 times 6x, which is going to be 30x. Right here, 5 times 6x, 5 times 3y, and then 5 times 6. So 5 times 3y is going to be 15y. Equals 5 times 6, which is 30. Then I'm going to have negative 3 times 8x, which is negative 24x. negative 3 times 5y. So look, here's the negative 15y. When we add them together, they're going to cancel. Negative 3 times 12, negative 36. Now we can add these together. Add both equations together and let stuff start canceling out. So right here we got 30x plus a negative 24x. So that's the same thing as 30x minus 24x, which is going to be 6x. 15y minus 15y, or plus a negative 15y, which is going to be 0y, so I'm not going to write anything. Those are going to cancel completely. Then I've got 30 minus 36, or 30 plus a negative 36. So that's going to be negative 6. Now I need to solve for that x, so I'm going to divide by 6 on both sides. Divide by 6. Divide by 6. So I should have x equals negative 1. Okay, once I'm at this point, we have now reached an easy place. So we just take that and we plug it back into the easiest equation to solve, which looks like the top one, so I'm going to plug it in up here. So you start rewriting that equation. When you get to x, because that's what we solved for, instead of writing x, you're going to write negative 1. So we have 6. Now we're at x, so I'm going to stop writing. See, we're right there. I'm writing this equation. So 6, I'm at x. Instead of writing x, I'm going to write negative 1, because that's what x is. Plus 3y, you can see we're writing that top equation, equals 6. So now I need to solve for y. So I have negative 6 plus 3y equals 6. Notice anytime I have parentheses like this, if there's a number outside of it, the first thing I do before doing anything else is I multiply that number into that parentheses, okay? So remember the order of operations, PEMDAS, P-E-M-D-A-S. The first letter represents parentheses, okay? So we're taking these parentheses and we're solving them before we can do anything else, okay? So we have negative 6 plus 3y equals 6. I'm going to add 6 to each side. So I have 3y equals 12. 3y equals 12. And then I'm going to divide by 3. Y equals 4. Okay. Now our last one, again pause so you can try this work, and then we're going to go on to substitution right now. And you can play it in just a second. Substitution, that's the idea of solving for one variable and plugging that into the other equation, then solving for a single variable. By that time you should have a single variable equals some number. Take that number, plug it back in, and get the other variable's value. Okay, so if that sounded confusing, just follow along and take some notes. So I want to start off by solving for the easiest variable. I think it's going to be this y right here. Now remember, if I'm going to solve for that y, I need to circle that negative. That tells me what kind of y it is. It's a negative y. So I have 2x minus y equals negative 1. I'm going to subtract 2x to the other side. I should have negative y. X's are going to cancel. Negative y equals negative 2x minus 1. Now I'm going to divide. When I have a negative y like this, I don't just leave it. I haven't solved for y. I need a positive y. So if I want that sign to change, I need to divide by negative 1. When I divide by negative 1, it pretty much is just changing every sign that you can see. So now I'm going to have y equals 2x plus 1. Notice it was a negative y, negative 2x, negative 1. Now it's a positive y, positive 2x, positive 1. That's what happens when you divide by negative 1. So I solve for y. I'm going to take y and I'm going to plug it back into the equation I haven't solved yet, or I haven't even used. Okay, and I'm going to rewrite that equation. When I reach y, instead of writing y, I'm going to write 2x plus 1, because that's what y equals. So notice, here's the equation that I'm going to write. 3x plus 2, now I'm at y, so instead of writing y, I'm going to put a parentheses, I'm going to put 2x plus 1. That's how, instead of writing y, you write what y equals, okay? And that's what y equals. Then equals 30. Finish off the equation. Now we're going to, again, here's parentheses. First thing I want to do is get rid of those parentheses, so I'm going to multiply through. So I've got 3x plus 4x plus 2 equals 30. So I have 7x plus 2 equals 30 when I combine like terms. So 7x plus 2 equals 30. And then I'm going to subtract 2 from each side. Minus 2 minus 2. I should have 7x equals 28. And then I can divide by 7. So x will equal 4. Instead of writing out the dividing by 7, I'm just going to write x equals 4 because I'm running out of space here. X equals 4. Alright, so what I do with x equals 4 is I go back in and I plug it into the simplest equation. So if I know x equals 4, again, this thing should be pretty easy from this point. So let's go ahead and plug it into the first one. Alright, I'm going to start rewriting that in y'all's notes section right here because I'm running out of space. So I have 2 times, instead of writing x, I'm going to write 4 minus y equals negative 1. So I have 8. Remember, here's the parentheses. Let's figure out that first. Minus y equals negative 1. Subtract 8 to the other side. So I have negative y equals negative 9. What I did here was I subtracted 8 just to show you. Okay, so these cancel. And then I have negative 1 minus 8. That's going to be negative 9. Now I need to change that sign on that y. So remember, I divide by negative 1. Divide by negative 1. So I should have y equals positive 9. And that's my solution. Now if I wanted to check these solutions, which is x equals 4, y equals 9, I plug them into these equations as x and y. And sure enough, if x equaled 4, 4 times 2 is going to be 8 minus 9 is going to be negative 1. Or 4 times 3 is 12 plus 2 times 9, which is 18. So 12 plus 18, sure enough, is 30. So that does solve both of these equations. Therefore, it is the solution that satisfies the equations. Alright, so guys, go ahead and turn this paper in to me whenever I specify the deadline to be, and you should get 10 points on your test. Thanks for watching, and I hope you learned something.